Hello everyone, I am Alexander Wong from Group 1, and my group mate is Wu Yufei, Lei Zhenxian, Alistair Gong, and Adelina Azwin. Now let me introduce our research topic, which is about capacitance and energy. So what is capacitance? The capacitance comes from the capacitor, which is used to measure the ability of a capacitor to store electric charge. In our daily life, the capacitor is quite useful as it can be used as an alternate energy source in many applications in place of other energy sources such as battery. This is due to its energy storing characteristics and it can provide an enormous amount of energy at a rapid rate. For example, we can use it on camera flash, audio equipment, active or passive filters, and so on. In our research, we will conduct an experiment to make a capacitor with common materials. Now, Yufei will explain about the theory.
Thank you to my group member just now. I'm Boon Yu Fei, and I will discuss about some theory before we look into our experiment. Generally, capacitor is a device that stores energy and behaves like a battery. The charging and discharging time depends on the capacitance of a capacitor. So the capacitance can be defined as the ratio of magnitude of charges on one of its plates to the potential difference between them. So here is the general formula of the capacitance. So in this case, we just focus on the parallel plate capacitor. The capacitor is built when two conducting plates are put parallel and E field is formed like this in the diagram here. So in ideal condition, the separation distance D should be very small to ignore the fringing field. We can see that the formula can be derived uh, like this. And from the formula, we can clearly see that the capacitance can be varied by S or D, while S is the surface area of the plates and D is the separation distance of the plates. So in this experiment, we are focusing on the parameters, which is separation distance only.
Hi, my name is Ben, and I'm going to talk about the apparatus needed. So we will need 5 A4 papers, a thick book, a multimeter, and aluminum foil. So first we prepare 2 sheets of aluminum foil, and then we will sandwich a A4 paper in between the two aluminum foils as a dielectric material. Next we will place a book on top, and then the capacitor is built. Next we will probe the open ends of the aluminum sheet with the multimeter, and then we will read the readings after some time to let the reading to stabilize. And then to repeat the experiment, we will increase the number of A4 papers used.
In this part, we'll be talking about the findings of our experiment. With one piece of paper being used, the measured capacitance is 7.3 nanofarad. As the number of paper is increased, the measured capacitance decreases gradually and will reach 2.46 nanofarad at 5 pieces of paper used. On the left, there is a graph which represents our data. From the findings, we are able to understand that capacitance is inversely proportional to the number of A4 paper used. In this experiment, a few layers of paper are used as dielectric to represent different thicknesses of the dielectric. As the separation between layers will contain air, we try to eliminate them with a heavy object. Unfortunately, the capacitor still contains some air, and the consequence is that the capacitance measured will not be ideal to our calculation values. That is all for my part.
In conclusion, a capacitor can be made by sandwiching two conductors with dielectric in between. So in this case, aluminum foil is used as the conductor while paper is used as the dielectrics. So the dielectric between the two plates provide mechanical support that allow the plates to be nearer with each other without contact. So the capacitance C can be varied by different parameters such as surface area or the distance between the conductor D. So we depended on the D for this project. We can see that the more layer of paper between the plates, the smaller the capacitance. So that concludes C is inversely proportional to D. So the greater the distance between the conductors, which is the thickness of the dielectric, the smaller the capacitance. That's all from us. Thank you.